Today's lesson is called Applications of Arithmetic Sequences and Simple Interest. So I'd like you to start by completing the opening exercise, which is a review of our previous lesson. Pause the video, try the question on your own, and then resume the video to go over the answers. Okay, so now that you had a chance to try on your own, let's take a look. The number of shaded squares shown in the patterns below forms the first three terms of an arithmetic sequence. So you have to count the shaded squares. So when the first term is there, it's 4. The second term is 7. The third term is 10. So you can see underneath where it says determine the number of squares that would be shaded in the 20th pattern. I went ahead and wrote down my first three terms and then did ... Now, I don't have room. I don't want to draw this out. The quickest way to answer this question is always going to be to create the formula. And with the formula, as long as you have the first term and the common difference, you can write the formula that will get you any number in the sequence. So taking a look at what I have, I see there's a common difference of 3. So in my formula that's on the formula that we went over yesterday, and also on the formula sheet, we've got a sub n equals a sub 1 plus d times n minus 1. So remember, we're going to replace a sub 1 with the first term, and we're going to replace d with the common difference. So our first term is 4. Our common difference is 3, and you can see I put those in the correct spots. And now, when they ask me about the 20th number, I can use my formula very quickly to jump to my answer. I'm going to find a sub 20 by plugging 20 in for n. And then once I do the math, I see that it would be 61 squares that are colored in. So now let's look at example 1 together. Laura is training for a marathon. In the first week of training, she runs 15 miles in total. She plans to then increase the amount she runs each week by the same amount. The following sequence shows the progression of how many miles she runs each week. So we see 15, 20, 25, 30. So question A, by how many miles does Laura increase her distance each week? How did 15 become 20? We added 5. How did 20 become 25? We added 5. How did 25 become 30? We added 5. So we can see that she's adding 5 each time. So how many miles does Laura increase her distance each week? That would be 5 miles. B, how many miles does Laura run in the 5th week? Well, if I take a look at what we have the first, second, third, and fourth term. 5th week would be the 5th term. I'm already almost there. So for this question, it's easier to just extend the pattern, continue to add 5. So I was at 30. I'm adding the common difference of 5. That gives me 35. So here, it was 35 miles then the 5th week. Now, when we go to do part C, how many miles does Laura run in the 20th week? This is much more of an extension. So the quickest way to answer this one, and always, is to write the formula so that you can quickly jump to those larger terms and figure out what the answer would be. So we definitely want to write the formula for this. So, keeping that in mind, we have our general formula, a sub n equals the first term, a sub 1, plus the common difference times n minus 1. For us, we're going to put in what we know. A sub n equals the first term for us is 15, plus the common difference we figured out in part A is 5, and then we have n minus 1. That formula will get us any term in the sequence. So when it says 20th week, we're looking at an n value of 20. So I'm going to find a sub 20 by replacing n with 20 in the formula. So that's equal to 15 plus 5 times 19, which is equal to 15 plus 95, which is equal to 110. So that means it's 110 miles at week 20. So we have all 3 of our answers for example 1 in real context. So arithmetic sequences are a special type of linear function because its domain is the natural numbers, 1, 2, 3, right? We have a first term, a second term, a third term, a fourth term, etc. We will now, though, look at another special type of linear function that occurs in the real world, whose domain is the whole numbers, 0, 1, 2, 3, and so on. So this is all about investment or loan. When you invest money with a bank, the bank pays you for the use of your money. So in that respect, interest would be something that you gain. When you take out a loan from a bank, you have to pay the bank for the use of their money. So that would be money you pay them. In both cases, the money paid is called the interest. Simple interest is computed only on the principal. It is used commonly in consumer lending and in mortgage loans. So we have some formulas here along with what the variables represent on the other side. So I is going to always be the interest. A is the accrued amount, meaning all together, like the total. P is the principal, which is your starting amount. R is going to be the interest rate, but just make sure you express it as a decimal. And T is time in years. So that means if someone says 6 months, I'm not putting in 6, I'm putting in 0.5, half a year. So over on the side are a few different formulas you can use. I equals PRT is only going to calculate the interest. Then the next three kind of calculate the same thing, but all in a different way. So one way to write the formula would be principal plus interest, but of course you have to calculate the interest first. So if you look at it that way, the one underneath has I spread out into PRT, which remember is the same thing as interest. Another way you can look at the formula is by looking at it as P times 1 plus RT. And the benefit of this one would be that it looks very familiar to another formula that we're eventually going to use that is on the formula sheet. This one is not. However, if you want to memorize it this way, like I said, it's very similar to one that is on the formula sheet that we'll talk about in the future. So let's look at example 3 together. Raul needs $200 to start a snow cone stand for this hot summer. He borrows the money from a bank that charges 4% simple interest. Okay, so first of all, 200 is what he borrowed. That's the principal, the starting amount. Then we have 4% as the rate, but remember, we have to write this as a decimal. So we're going to move that decimal point 2 places to the left or divide by 100 to see that that's going to be R equals 0.04. So now when it says calculate the interest, I'm just going to use the plain interest formula. So this is the first way you can do this. I equals PRT. So that means the interest is calculated by taking the principal, which was 200, times the rate, which was 0.04, and timesing it by the time. They just want to know for 1 year. So the time is 1. So when I multiply all those things together, I get 8. So now I can calculate the total by finding the accrued amount, which is the total, is equal to the principal plus the interest. Because I already know the interest. So the accrued amount or total is the 200 I borrowed plus the interest I have to pay, which means I'm going to pay back a total of $208. Now, if you had used the formula A equals P plus PRT, you could have found that in one step. That would be like combining 1 and 2 together. Okay? So in B, it says calculate, or let's continue to calculate the interest in total that Raul would owe if he waits 2 years, 3 years, and so on. So first of all, let's think about 0. No time has gone by. That's the same as what you borrowed. So that would be 0 interest and you borrowed $200. The first year, the interest was 8 and the total owed was 208. We already did that one. If I wanted it to be 2 years, I would have the same formula up top, but I would do 200 times 0.04 this time times 2. That would give me 16 for a total of 216. 3 years, I would do 200 times 0.04 times 3. And I would see that it's $24 and 224 as the total. And because this is simple interest, what you'll see is we are just adding 8 every year. So I can figure out the next one by just adding 8. Adding 8 to 224 is going to be 232, and I must have paid 32 in interest. So now in point C, it says write a formula, part C, write a formula for how much he will owe after T years. So we want the full formula. So going up here and looking at it, the first one I'm going to use is that third one down. I could write it as A equals the principal plus the principal, the rate, and the time, which is the interest. So I could write A equals 200 plus 200 times the rate times the time, which we're going to leave as T because we want to be able to find it in general. So this formula would be A equals 200 plus 8T, which should look very familiar to Y equals MX plus B. It's just that they have the number first and the number in front of the variable and the variable second. The other option for how you could write it would be using the fourth one down, the one with the star. So if I use that one as my model, I'd have A equals the principal times 1 plus rate times time, which means I've had A equals 200 times 1 plus 0.04T. And I could leave it like that, or of course, if I distributed, I would get the same thing that I got above. So there's the formula that will get me any information about that scenario. So I would like you to complete the practice questions. If you're in class, we'll use numbered heads together. If you're watching this video on your own, you need to complete these questions by yourself. Pause the video right now and try them, and then resume the video when you're ready to go over your answers. Number 1, Raymond bought a car for $40,000, which is great information to have, but irrelevant to us for this problem. What we want is he took a $20,000 loan. The interest rate is 15%, and it's a 3-year period. So P equals 20,000. The rate, not 15. You want to change it to a decimal, 0.15, and time T is 3. So I use the formula A equals P plus PRT because I don't know the interest. It's going to have to get calculated. So I plugged in 20,000 for both P values, 0.15 for R, and 3 for T, and I calculated that it was $29,000. In number 2, you have a small amphitheater, and they gave you the start of the pattern. They said the first row was 6, and the fourth row was 18. So I kind of drew that out and showed you 6, we don't know, and then 18. So whenever we have this situation, you want to pick the term that they give you, which for us is A sub 4, the fourth term, and use that to work your way backwards. So in the formula for the arithmetic sequence, we're going to do A sub 4, which means in n spot you want to put 4. The first term is 6, so that can go in for A sub 1. And it basically simplifies into 18 equals 6 plus 3D. So we would minus 6 from both sides, divide by 3, and see the common difference was 4. So now that I know that, I can write the actual formula for this sequence, which is A sub n equals 6 plus 4 times n minus 1. And I can find the 20th term by doing A sub 20 and replacing n with 20. We should find out that there's 82 seats in that row. Number 3, Doug made a 3-year investment. The interest rate was 4.5%. After 3 years, they're telling you he earned $675 in interest. I want to know how much was the original investment, which means I'm asking you to find P. So you're working backwards in this problem. In for interest, I would use I equals PRT because you're only talking about interest here. So I would put in 675, then P stays P, and then for the rate, we should have 0.045. We're changing it to a decimal, and for time, we should have 3. So we'll multiply 0.045 times 3 and get 0.135. And then we'll divide by that to get P alone and see that it must have been $5,000 for the original investment. Then lastly, you borrow $6,000 from a loan shark. If you will owe $7,200 in 18 months, what would be the simple interest rate? So I chose to use the A equals P plus PRT formula, and I filled in everything I know. I know the total is $7,200. I know the principal was $6,000. I don't know the rate, so I keep that in R, and I put in 1.5 for the time, not 18. 18 was in months. We always plug in years. Then I can solve this equation to work backwards, and I get 0.13 repeating, which is the same as 13 1/3%. And that concludes our lesson on applications of arithmetic sequences and simple interest.